I can come drop in these 4 pieces of timber off the semi-truck in 2 hours. Or we can sit there and form this all up for the concrete and then put all the rebar in, and there's a ton of rebar reinforcing that goes into all of that and other reinforcing metals. Then we can pour the concrete, then we can sit around and wait for it to cure before we can strip the forms and keep moving.
Something big is happening in mass timber, literally. Columns and beams are getting bigger, fire ratings are climbing, and with them, new possibilities are opening up. Faster builds, fewer members, and systems we haven't even seen yet. Today's guest, Corey Hokanson, is one of the sharpest minds in mass timber and someone widely respected across the industry for bridging the gap between ambitious mass timber designs and practical execution. Around the industry, he's known as the systems wizard, the person project teams turn to when the math gets messy, the specs get heavy, or the solutions don't yet exist. He's the design manager at SmartLam North America. They've got 4 facilities, 7 CNC machines, and coast-to-coast production in multiple species. In just the last 2 years, SmartLam's shipped more than 2,700 truckloads of engineered timber out, and to date, they've delivered over 500 projects. This episode dives into getting into something new, supersized structural elements. Think glulam up to 24 inches wide and 48 inches in depth, and panels strong enough to replace concrete podiums. In this episode, we explore where these massive beams can go, from podium slabs and parking decks to structural spans that used to only be possible with steel and concrete, into what it takes to use them well, from 12,000-pound panel logistics, 4-foot-long screws, to install sequencing, field cut limitations, and tool constraints. And then we get into why this is a turning point, as SmartLam turns hand-glued, one-off mega beams into high-precision, press-made components at scale. If you're in design, engineering, or construction, and you're curious about what mass timber can really do, this conversation is for you. And before we dive in, early bird tickets for the Mass Timber Group Summit are closing soon. Come connect with leaders like Corey, see the materials up close, and get inside the smartest room in the industry. Go to masstimber.group to get your tickets, and make sure to use the code PODCAST, all caps, for an extra discount. So with that, let's get into it.
Mass timber's always been big, right? I would say we were showing off the next step of that, going from mass to massive or massiver. I don't know what the next word will be.
I like massive.
Massiver timber. I'm okay with that. So most of our timber in the past has been what we call just regular glulam, right? It's 1 board wide by however deep it gets. Those get up as big as 2 by 12. Anything past that, you have to go to multiple boards wide. And they've been pretty rare in the past for those wider beams, but our new factory down in Dothan can actually produce beams up to 2 foot wide by 60 inches deep. 72? Might be 72 inches deep we can actually press, although our CNCs are 48 inches deep. That's a massive beam. So we brought them to the conference. We're like, we're going to show these off. The columns were 2 foot by 2 foot, and everybody came up and we're like, oh, these must be hollow. And it's like, no, these are solid wood pieces. And then the countertop, which we actually routed our logo into and everything, was a lot of fun. That was solid, 24 inches wide by 42 inches deep. And those are some of the first pieces that actually came off of our new presses down in Dothan. We wanted to show off what that can do. And it's really the start of this next step in mass timber for us. It's still, a lot of it's the same, but there's a lot of things that change when you start getting into pieces that big and that heavy. So,
What does change, right? Like what new opportunities open up if you have mass timber elements that are this big?
yeah, that's fair. I would say really there's 2 different categories of major uses for pieces that big, right? They're either dealing with really, really heavy loads where they require that much timber to be strong enough, or they're wanting the fire resistance out of it. So I know Timber Lab and some others just did a study with some Simpson connections, and they managed to achieve a 3-hour fire rating with mass timber elements with off-the-shelf connections, which is game-changing, right? Before, that's always been very proprietary, custom steel and or concrete to get those kinds of fire ratings, and that limits you on how you build it. So having timber that can char for that long, and the pictures from that test are pretty extreme, right? It looks like there's nothing left because at the top it's like this big column and then it comes down to like this hourglass shape. And so, but it survived. That's after burning for 3 hours. You figure 3 hours, that's a long time. You can get a lot of people, everybody out of a building in 3 hours. So those are some of the most extreme fire ratings that you get anywhere is a 3-hour requirement. And now we have the ability to do that out of timber and to make these pieces that are gorgeous and work for everything from structurally what they need for the loads, and they're fire rated and they're safe and they're environmentally friendly. And so people are like, let's take a look at this. Let's go build this. Um, so that's kind of what drives people to want to use these pieces. And then we get into the intricacies of, well, what do you do? How does that work? Right. Um,
And
in some ways, sorry.
no, you're fine. And so I've seen some of the pictures up, and we'll throw them up on the screen. But just so I'm on the same page, it's not just that it's 3 hours, but it's 3 hours of exposed timber, like it's not encapsulated in gypsum or anything like that.
Yeah, and not just 3 hours of being near a fire. That's they put it in a furnace and basically blast it with a blowtorch for 3 hours, like a big so that's intense fire, like, you threw it in a bonfire for 3 hours and it's still structurally strong. No coatings, no intumescent paints, no drywall wrapping, it's just timber. It's the same principle as always for mass timber. It's the difference between burning kindling and burning an entire log, is that it chars the outside and you're left with this outside layer. Um, and it makes sense. I mean, I just burned a pile of scrap trees that had fallen down over the winter in my yard, and we lit that. Let's see, Saturday. Today's Tuesday, so 72 hours later, it's still smoking and smoldering and hasn't burnt all the way through a log that was about 18 inches around. Right. So if you get a column that's 24 by 24, same thing. You're not burning all the way through that in any kind of reasonable time frame, and so there's plenty of time to get everybody out and to get the fire department there, and it's still structurally strong afterwards. You don't have to worry about it getting weak because got hot and lost its tempering or anything like that.
And so now that we have the ability to domestically produce these massive beams and elements, and we've got the 3 hour fire rating data to go with it, where in buildings does this start to replace what was previously only concrete or steel or super custom setups?
Yeah, we're still a new industry and people are still trying to figure out all the places that it makes sense. Some of the early uses we've seen, actually a podium. So typically on a large building, you get a concrete podium that's your parking garage. And then above that, you get your regular framing for the rest of the building. And that concrete podium has to take the weight of that entire building up above, and it has to be ultra safe from fire because it's a parking garage, right? If a car has a gas leak or whatever, you can't have it taking down the whole building. At least I assume that's why they're fire rated there. I'm not a fire expert, but anyways, they we're starting to see interest in that actually. So that top level of the podium is becoming mass timber in some projects, and so that's a crazy spot. Like, not that it doesn't make sense to do it, but that it's crazy that we get to do it because that's always been concrete, and it's so much concrete. Hold that whole volume out and say, hey, this is now timber, and just the schedule savings you're looking at there, where it's like, oh, well, let's see, I can come drop in these 4 pieces of timber off the semi truck in 2 hours. Or we can sit there and form this all up for the concrete and then put all the rebar in. And there's a ton of rebar reinforcing that goes into all of that and other reinforcing metals. Then we can pour the concrete. Then we can sit around and wait for it to cure before we can strip the forms and keep moving. That's an entirely different schedule proposition, right? So we talk about a large and labor savings, talk about a large portion of the building. And all of a sudden, not only are we saving all this carbon, are we saving all this environmental impact of the concrete, but we just saved weeks, which is real hard money for the developer and the contractor and makes everything just that much smoother.
Is,
Right.
is this all hypothetical what if, or are you guys actually working on buildings at SmartLam that might be taking advantage of this?
Well, a year ago when we were planning the mass timber booth, first talking about it, right, we didn't have any beams that big. We hadn't made any beams that big yet. Today, yeah, we have projects right now in the works that are using beams of that size, up to 24 inches wide and up to 4 foot deep. And the one podium that I'm talking about actually has 9-ply CLT over the top of these giant beams. So it's replacing all that concrete, not just the concrete beams, but the concrete beams and the concrete slab that would be over the top of it is being replaced with 12.5 inches of solid CLT. And that's another interesting scenario because it's CLT. It's like, yeah, it's the same. It's 3 layers, 5 layers, 7 layers, 9 layers. Like, yeah, we can make that. That's no big deal. And then you go, oh, that piece weighs 12,000 pounds. Huh. Well, we better make sure it's in the right order on the truck because if that shows up in the wrong order and you have to move that somewhere, where do you set a 12,000 pound piece of wood and not hurt things. How do you move that? How do you attach that, right? If you normally, oh, you got plywood over joists and you use a 3-inch screw or whatever to go halfway into a 2x4 for a half inch of plywood. Now it's like, well, 4 inches of CLT, cool. We use a 7-inch screw. Not that big a deal. 12.5 inches of CLT? Yeah, you're not going to find a lot of 16-inch screws at your local hardware store, if any.
And so I heard you say two things: that it's wonderful and it's awesome that we're gonna be able to use this in certain applications, and maybe we don't even know all the opportunities that it's gonna open up. But there are some things that we got to consider that are gonna be completely different. I heard one thing about maybe sequencing, transportation, and then connections. Let's unpack those.
Yeah, well, going back to that logistics side, right? If you're dealing with concrete, you pour concrete for the whole building, right? It doesn't matter. You don't have truck one and truck two being different. It's just I have X numbers of trucks of concrete that have to show up, and we're going to pour it all. I'm sure there's more nuance to that. Again, not a concrete expert, but for the most part, at least for the trucks, what's in the concrete trucks, it's the same on everything. For mass timber, with these pieces this big and it being basically a puzzle piece, you want them in the right order. And having that sequence thought out ahead of time makes all the difference on site, because if you get partway through putting it together and you're like, oh, I should have put that one in first. Now I got to go pull 3 pieces out in order to then put this piece back in, and then do that. Well, you don't want to do that. It's more work. You're losing all that time schedule savings, right? So there's some logistical planning that's involved in that. That's the cost. The benefit is that it goes together like a smooth puzzle. So once you have that planned out and it comes together, again, you've got an install crew that's way smaller. So if you've ever watched a crew of people installing a non-mass timber building, a steel and concrete building, there's people everywhere tying the metal, putting forms, doing everything. And on a mass timber install, you might have 5 or 6 people. So you've got one, over there helping rig up the things for the crane, maybe 2. You've got a couple people up there at the top directing them and then putting screws in. And that's much smaller crew, much lighter logistics on that once things show up. It's just you have to pre-plan it, which you guys have talked about on the show many times. But
Yeah, yes, absolutely. And with the bigger members, I imagine you can get better strength ratings, span farther, so you probably maybe might need less pieces, which translates to less pit, all that kind of stuff.
it certainly can. Again, that goes back to what the reasoning is for needing the bigger pieces, right? So we talked about the fire ratings. The other times people use pieces this big is when they need it for all the structural load. So when we go back to early days of mass timber, which sounds funny to say, right? The CDH hanger from Simpson was a 9,000 pound capacity for their 9.75, and that was the big hanger. And then you went up to, they released the ACDH, and it's like, that's wonderful. This has 20 kips, and now we can double them up and we get 40 kips of capacity out of this connection. 40,000 pounds, that's a lot of weight. That's a lot of trucks. I mean, that's an entire semi-load worth of stuff hanging off of these 2 brackets, right? Well, now we get projects where they come in and it's like, oh, well, I'll put it this way. One of the engineers I was just talking to on a project said, hey, yeah, we can use the Simpson for all of the light connections under 40 kips. And I'm sitting there going, I've never heard 40 kips described as light before, but now that's light. Okay, what's your heavy one? Oh, 100. Okay, yeah, we have connections here of 100,000 pounds from beam to a column. That's going to take a lot of wood. It would take a lot of steel or concrete too. It's a lot of load, right? So places that before couldn't be timber because they had that high of load. So you see a lot of hybrid buildings where there's steel elements. And I'm not saying that's a bad thing. There's still places for that. But there's opportunities now to do things out of timber that previously would not have been possible at all, because now we can make big enough pieces to actually handle those loads. But if that's why they're being used there, it's probably not less pieces. They're just being loaded very heavily. But yeah, there's also the opportunity to increase the spans by going thicker and potentially drop the number of beams, drop the number of pieces, which can pay off. There's a cost benefit analysis that has to be done there for every given project to say, hey, what is the best here? Like, we have this design, and just totally spitballing here, but if we have a building and we have columns every 10 feet, and so we get a grid is 10 by 10, all the pieces are going to be pretty small. If we double that to 20 by 20, the pieces are going to get bigger, but the number of pieces drops. So do we end up with more fiber or less fiber? Do we end up with more? Well, that's one cost. How about our connection cost? The connections, we get less of them, but they're more metal each. So does our total connection budget go up or down? And then install. Does our total install budget go up or down? Well, it's less pieces, so it almost certainly goes down. So at some point, there's going to be a break even, right? Where you go too far and all of a sudden we're spanning 50 feet and everything's custom and it's super expensive and heavy. And we've crossed that line to where we're back to more expensive by going bigger and larger spans. But on the other end, like if you go too small of spans, you've got way too many pieces and you're more expensive. So somebody has to run that on every project. Um, Presumably that's the structural engineers kind of doing that, but a lot of times the mass timber companies, that's where we'll step in and help with the value engineering or the design assist to say, hey, here's what we think makes the most sense based on what we see that you're doing. Um, and then kind of try to figure out that happy middle of what does pencil out the best for your project and your goals.
Does that fall under the job title systems wizard?
Oh, I love that title. Uh, no, not directly. So I work with a lot of the wonderful people that do that work. So Jim Henjum, our director of engineering, his team is specifically over all of that delegated design or design assisting for figuring out what makes the most sense with the math and the numbers. My role as systems wizard is more for the CAD design in our production systems to say, okay, we got the numbers from them as to what we need structurally. What makes the most sense for what we can cut, for how we can cut it with our CNC, for how we model it in our software, for how we track it through production, for the brackets we can buy from other, like what makes the most sense there to standardize it and to get everything cost effective and functioning together. Because we come up with this really cool idea and it works great, but I can't cut it on my CNC. Doesn't really matter.
Yep.
Or we come up with this great idea and it saves half the fiber, but it requires a screw that doesn't exist. That doesn't really matter either, right? So it's holistic. There's a holistic approach that's needed for all of these projects. Again, one of the things you guys talk about all the time is you can't do this in a silo. So I think everybody, engineer, architect, builder, manufacturer, and then even our suppliers for the fasteners and the brackets, they all have to work together to actually be open with each other about what makes the most sense and what's easiest for them. Because if you don't speak up, you get stuck with something that wasn't best for you and maybe it could have been, and you just didn't ask. So we get that all the time, honestly. Like we'll get plans where they're like, oh, hey, here's your plan set, and we've already panelized it and split it into panels for you. And it's like, well, I see what you're going for. Can I do it like this instead? And most of the time they're like, yeah, sure. We were just trying to help. But if that's more efficient for you, go for it. Sometimes they come back and they're like, no, it's very specific. It has to be panelized that way. And we say, okay. But asking that question can be very helpful.
For sure. Inside of like figuring out what's capable and doable and efficient, we had talked a little bit before we hit record on like, hey, the install side of things, like you might need a 4-foot screw to put some of these assemblies together. Not a ton of those out there, but it's not just do we get the 4-foot screw, it's how do we drive that 4-foot screw and not burn up thousands of dollars worth of tools in the process. Like what would you say to the installers listening right now thinking about that?
Yeah, plan ahead. Mass timber is not, it's not off the shelf, right? There's most of the connections, most of the screws are not things you're going to find at Home Depot. Most of the tools you might find at Home Depot, but the reality is there just aren't a lot of tools specifically designed for mass timber yet. So for the most part, people are using tools from other industries and just making them work. For these bigger, longer screws, they need a slow spinning, high torque drill to drive these things. And it's kind of tricky, right? You have to drive that screw, and if you stop halfway through and it cools down, it's going to bind up and you're stuck. Like you're never getting that screw the rest of the way in or back out. So you have to drive it in one go, all the way in. And again, you're dealing with 4-inch screws, no big deal, right? Odds of your battery dying during a 4-inch screw, not very big. Odds of the battery running out during a 4-foot screw, a little better. Have an extra battery, right? On top of that, these woods, southern yellow pine especially, it's really dense, and so it takes a lot of work. And these drills, these batteries get hot, and so even putting together that booth at the Mass Timber Conference, which wasn't big, we had times where I had to pause and set the drill down and say, we're going to take a break and walk away, because otherwise I'm going to have a paperweight here in a half hour. Obviously on a job site, you can't take a break and walk away. So you have to have extra drills with you that you can swap back and forth on. Hopefully that changes. I mean, we hope that as the industry grows more and people take more interest, there will be more drills designed specifically for what we do. And until then, we're just use what we have. But again, you have to be very careful too. And with what drills and drivers you use on which fasteners. Every fastener manufacturer has different requirements. Some of them allow impact drivers, some of them do not. Some of them say yes, but only on certain screws up to certain sizes. And you have to be careful to follow that, because if you use the wrong drill on the wrong bit, wrong screw, all of a sudden you might have, it might be bad, right? You could, worst case scenario, you're taking all those screws back out and replacing them all because you voided the warranty or whatever on that manufacturer's thing, or you broke the screws off because they snapped because you put too much torque on it.
Yeah.
And that can be a real pain. Like, you put too much torque on a connection from steel to wood and you pop the head off the screw. How do you get that back out? Like, there's no easy way to pull out a 10-inch screw that's missing a head.
Yeah.
And in the worst case scenario, you're actually replacing the entire beam. Like, we've had projects where you replace an entire beam because the screw head snaps off. And that's not fun.
I don't think that's fun for anybody.
It's rare, thankfully. I mean, people are really careful, and for the most part, you design things to where you can deal with a little bit here and there, but every once in a while something goes wrong. It's like, yep, that one, for whatever reason, I can't repair it adequately, and the engineer is not comfortable with it, and you end up making a whole new piece, which, when they're that big, can be, not only is it money, but it's time, right? You got to wait for us to press it, cut it, ship it out to the job site. There's a lot of well, it just changes the game, right? Again, if you're dealing with 2x4s and light stick framing, if you break a 2x4, you're out a few bucks, maybe a little more depending on inflation at the time, right? But you got a 10,000-pound piece of wood and you somehow damage that one or break that one or mess it up, then that's a lot more digits on that price tag.
Yeah. So on that thread, on that vein, if you're sitting there looking at a project that's using these massive elements, what would you say? What would your conversations look like with designers or engineers to say, hey, let's get the most out of this, or really pay attention to these unique aspects?
Yeah, pay really close attention to the connection detailing would be my main one, right? Working on that booth at the Mass Timber Conference, again, that was smaller by comparison to some of the things we're talking about now. But even then, there were things I learned putting it together where it's like, oh, that doesn't work. So one of the details we had is to put a screw through the beam straight down into the column underneath it. It's like, cool, perfect, makes sense. But because of the length of the screw that we could get, we wanted to overdrive it 2 inches into the beams. That way it gets enough thread into the column below it. And as I'm working on it and trying to put the thing together, I realized that, for a screw that size with the Torx head that it has, there aren't any conveniently available extensions for a drill. So sinking it 2 inches down is actually not trivial. I had to go to multiple stores to go find a socket branch extension. It was not rated for the tools I was using, but it was good enough to get that bit in. And it's like, oh, that's a concern I'd never really considered about, is with normal drill, normal screw bits, you can just buy an extension from anything and put however long on the drill that you need to get that screw in. And here it's like, well, that may not be a factor because you've got these T50s that are, that big around on the head of the actual bit. And the extensions for them may or may not exist in local area. And I did not think ahead to buy them off the internet or order them ahead of time because I didn't think I'd need it. And then I get there and I'm like, oh, that's a problem. So I ended up having to counterbore each of the holes 2 inches in order to put the screws in and deal with it that way. And it's like, well, that was not ideal. So
How much conversation have you had with like the installers that are, going to be working with this material, the bigger material, maybe, near or long term in the future, et cetera? Have they had any feedback, or have you had those conversations?
not a lot of it's been installed yet. So, I mean, as people start working with the bigger stuff, we get more feedback from people about it. I mean, that's the same basic genre of feedback, which is the bigger it is, the harder it is to field modify, right? Like, you talk about cutting through a piece of 3-ply CLT, it's difficult, but 4.5 inches, you can do that. You can get a skill saw that can do that. With the saw squatch, 12.5 inches, no, that's chainsaw territory for any kind of cuts, right? And even drilling a hole through that, like, again, going back to that booth, on our countertop, I drilled a hole through it, the beam for our plugs to put some outlets on top to charge phones. And I was like, no big deal. I'll just drill a hole through it. I've drilled holes my whole life. I've worked in construction. Did not realize how long it would take to drill a 3-inch hole all the way through a 42-inch deep beam. Because it turns out that all of the drills that are made for drilling holes through wood are made for either drilling holes through 2x4s or double 2x4s, maybe triple 2x4s if it's a really tall top plate, like if it's an extra sturdy wall section. And so after about 4 inches, they start bogging down in the sawdust and ended up having to just back it out every half inch and suck the hole out with a sop vac. And so it took two of us, one up there drilling, the other one down at the bottom, and just go down, go up, vacuum it out, go down, go up, vacuum it out, and took about an hour per hole to drill these holes through this beam. It's like, yeah, we need to be really careful on detailing, because if you put a hole all the way through something like that, you're talking about massive amounts of labor time for somebody to field cut this. Like, that needs to all be coordinated and cut in CNCs or whatever if they can, because it's not as simple as just, oh, I'm just going to go drill a hole.
So I'm assuming that the new facility with the CNC that you guys have, you can do those in the factory, correct?
For the most part, yeah. I mean, we can cut beams big enough that I can't drill all the way through them, which is both cool that I can cut them and unfortunate that I can't drill all the way through them. But it's just a matter of drill bit sizes and widths and things. But we can at least drill almost all the way through, even the biggest one, and then you can finish it by hand on those larger sizes, right? Which at least makes it much faster. The challenge is, same as always, coordinating. So I ran into the same problem my projects do, where I did not have my electrical stuff coordinated ahead of time. So instead of cutting it on the robot, I was like, I'll just deal with it in the field. And then I regretted that choice. I should have taken the time and found the time to figure out the electrical ahead of time and say, this is where we're putting it, and have it all shop cut. But I didn't.
So it kind of goes back to the cliche, the thing that I said I didn't want to bring up again and again, but you really got to bring everybody to the table, especially like it's even more amplified now.
Yeah.
Yeah.
So yeah, the bigger these pieces get, the more it becomes important. Because, like, again, even drilling through, like, I've got a fire sprinkler's got to go through the side of a beam. It's like, okay, if it's 5 1/8 inches wide, that's not too bad to drill a 3-inch hole through. But if it's 24, and there's a lot of them, it's really bad to drill the hole through on site. You really don't want to have to do that. So it becomes even more important to get everybody coordinated early. And yep, it's that cliche.
Yep. So what do you think is the most exciting aspect for you personally, being able to work with like these huge members?
I think for me, my goal has always been to standardize, right? So I want to see solutions that exist and have been proven that can do most of what we do in construction. And I feel like mass timber has been mostly in commercial, governmental, office type spaces in the past. Um, and so I'm very interested in what this will do to some of those other, like podiums, for an example. If you can take over even a small portion of podiums, that's a massive impact on overall environments and construction timeframes and all of the above. And not just the carbon impacts, but just the ability to get things built, right? We are short houses by a massive amount in this country. And while this won't help small individual residences, it can definitely help with large apartment complexes and things like that. And making places that are better to live in, better condos, better examples like that. And so the more things that we get figured out and proven and say, hey, here's details that work, here's connections that work for loads all the way up to now, say 100 kips instead of 40, that just changes the rules. So now there's more options for people to go through and find out what they want to do next.
Yeah. Yeah. I like that answer. The if you were sticking, or if you were having a conversation with a designer and you're like, hey, we can do these 4-foot deep beams, 2 feet across, etc., and they said, that's cool, but how is it really like relevant to me or what I'm doing? Like, what would you say the big pro to the design community specifically would be? It's like, hey, you should really look into this application because I think it could really benefit in X way.
It might not, honestly, right? I mean, unless they're dealing with those ultra high loads or ultra high fire ratings, that in and of itself probably isn't a huge factor. The number of 24-inch wide by 48s we're going to get, pretty slim. But the ability to make them is very exciting. So what if you have a spot where you need a low clearance and you need a heavy load? Well, maybe you go 24 by 12. So instead of having to go deeper, you go twice as wide, and we can make a wide, shallow, narrow beam, right? Or the point is, we can make anything in between this and this,
Right.
And so whatever size shape you need, it's coming off of our presses down there. It's a fully automated system. We can churn out beans every 15 minutes. We can churn out a press load of beans down there. And that's can be a lot of wood, right? So there's projects where before it was like, ooh, I don't know, that would have taken however long it's going to take to glue these beams up by hand. Because they used to, for the most part in North America, they used to all be glued up by hand for these larger beams. And now they're coming through a press that's automated and we can churn out dozens and dozens and dozens. And all of a sudden, these big projects are like, sure, you want 600 pieces? Okay. You want 1,000 pieces? Okay. And then you need a giant piece with it. Well, now you don't have to go get somebody else to make that extra giant piece. We can make the giant one that you need for the showcase piece in the middle of your lobby where it needs this extra heavy load or whatever because it's a massive span. And we can make all the other pieces for the rest of your project too. Or maybe you have a project where it's all heavy and you need everything to be that big. But I think for the most part, it'll be mixed in between things, not an entire project. Unless it's a podium like that, in which case maybe.
You mentioned, hey, these bigger members, traditionally, you have to lay them up and glue them by hand. Now you guys don't have to do that. Are there any benefits to doing that in the factory, like as terms of like quality, anything like that?
Well, yeah. I mean, obviously, right? Anything that gets machine automated tends to be more consistent. We had a lot more control over it. So if you saw the beam there at the conference, right, a lot of people walked up to it and knocked on it. Like I said, they knocked on the column, see if they were hollow. They knocked on the beam to see if it was hollow. They went to the end of the beam and saw these boards. And it's like boards. And you could count each of the individual 2x. And I sent a picture of it to one of my friends and they're like, wow, what's that? You make that out of like 1x6s? That looks tiny for each piece. And I was like, no, that's just how big the beam is. There's that many 2x in it. But if you noticed at it, there's no gaps, right? It's tight board to board all the way through that entire beam. That's incredibly difficult to do by hand, right? That requires some advanced robotic automation that we have that actually glues the boards together side by side first in each layer before gluing the layers together to get that completely homogeneous layup. But that matters a lot when you're dealing with these connections because, well, if there's a gap between two boards, yeah, it still technically meets code like APA, ERG 320. Sorry, that's CLT. 119 and 191 for glulam. They allow gaps and tolerances. Like that's acceptable. But then if you're going to put a connector into it and that screw goes into that gap, what happens, right? Simpson's got a proven, like they have an actual study and a formula for how much you have to reduce the capacity if there's gaps between boards. We don't have to worry about that because there's no gaps between the boards. So you're going to get a more consistent, higher capacity out of your connections and less things you have to worry about by going with an automated machine like that. Plus, it's just faster.
Yep. Yeah. No, that makes a ton of sense, man. Well, this is exciting stuff. When we were walking by the booth and we saw those, you know, just massive beams and then the tabletop that you guys are talking about.
That's so big.
Yeah, we got to talk to Corey and see what's going on with this. Like, and, you know, these big beams and elements like we talked about before, it's like, it's not that we couldn't get them previously, but it's like now we can make them in a factory domestically. Do I have that right?
Yeah, I mean, people have been making big timbers forever, right? So big glulam is not new. Big glulam, like Western Arch Rib and QB and Zippo and Lamco, there are companies that have been making massive glulam pieces in North America even for quite a long time. They're just all made by hand. Everyone's a custom layup. It's made by hand. It's cut by hand. And that means that they're not like getting one or two for a project is fine. Like you can get a few for a project. You can even be Portland Airport and get a bunch of beams that are made. Like they've got these big curving, swooping beams, and that's amazing. But it's not a commodity level product. It's a very custom, very niche and expensive product because of that. And not just because of what it costs, but because they can't make an insane number of them every week. Yep. Right. So if that goes from, hey, we can make 5 of these to we can make 100 in a week, that changes the buildings you can consider using it in.
Totally. So,
and Europe has some of these factories, right? They've been making beams like this, but then you're dealing with Europe and you're dealing with the spruce wood instead of the Doug fir, the Southern Yellow Pine. And then you're dealing with shipping and potential tariffs or whatever, all the things that are Europe, right? They make beautiful pieces of wood. They do. But I love the fact that we have capacity to make them here locally now.
Yeah. Yeah, absolutely. So if, you know, last impression for somebody listening, what do you say about what you guys are able to do now?
Well, what I would say is don't assume that we can't do something, right? A lot of things that were not possible a year ago or not feasible a year ago are back on the table now. or not back on. They're on the table for the first time for mass timber. So if you've had a project in the past where you're like, oh, this just didn't pencil, it didn't make sense, it's time to revisit it. Not necessarily that project, but for your next ones, right? Take a look and say, hey, let's throw all those assumptions out the window about what we knew about cost competitiveness and feasibility and all of these things, because everything has changed in the last couple of years, which just feels facetious. It feels like hyperbole to say that, because like, oh, it's just mass timber. It's like, yeah, it is. But at the same time, the industry's grown a lot in those 2 years. We've got bigger screws, we've got bigger fasteners, we've got bigger brackets, we've got bigger beams, we've got bigger panels, we've got more factories and more robots. I'm not just talking to us, I think the whole industry has more factories, more CNCs. And so we can do things that are a lot cooler, a lot better, and let's just do more of it.
Yeah, I love that answer, man. Well, thanks for unpacking this with me. I had a ton of fun, learned a lot, and I'm excited to see you guys again soon and watch what you guys, those little secret squirrel projects you guys got in design come to life.
Yeah, it'll be fun for sure. We'll have to do a follow-up and show you around one of those buildings when they get built.
Yeah, sign me up. I'm there.